Hi students, today we're looking at section 2.2, dividing radical expressions, and our objective is to multiply and divide radical expressions. So square roots are only one of those. We have cube roots, fourth roots, and so on. So I'm going to give you the video with the writing already on it because it took 21 minutes to do the video and it was just way too long. So I'm going to send another one. So dividing radical expressions, you have two rules that you really want to pay close attention to. First of all, you must have the same index to use these rules with your couple of roots that you have. To combine them with products, you want to multiply them. The square root of a times the square root of b is equal to the square root of a times b. And the quotient, for the quotient rule, you have the square root of a over the square root of b is equal to the square root of a over b. So there are a couple examples here. The one that always rings home for kids or students, if you have the square root of 4 times the square root of 4, usually think for a second, you go, oh, it's 4 because it's 2 times 2. But if I give you the square root of 7 times the square root of 7, it might not be so clear. So it is 7, just like the square root of 4 times the square root of 4. Okay, and the next one, sometimes you have a root, the square root of 3, which is irrational, times the square root of 27, which you could simplify a little bit. But if you bring it together, you get the square root of 81, which is 9. So you're able to simplify it then. So, and then the same thing with the square root of 200, x to the 7th over 2, the square root of 2x cubed. You can simplify those by bringing them together as one of the quotient of the roots. So we often say the quotient of the roots is equal to the root of the quotients. So then we can simplify it to the square root of 100x to the 4th, which is 10x squared. Now remember, our variables that we're dealing with now are assumed to be positive values. Just keep that in mind. Okay, well, we started with a number value. And if you look at the FOIL method for this, when we use FOIL, we have the first, outer, inner, last. And you can kind of see as I have that all together there, that each of those products, there are 4 products with a FOIL, two terms times 2 terms. And you simplify each term, noting that second term has a coefficient of -1. So -1 root 5 minus 2 root 5, that will give you minus 3 root 5, and then add the 2 and the 5 and you get your answer, okay? So pretty easy. And then with the other one, with the FOIL, I took the time to show you the little scratch work that I would use. And I might recommend for you, if you're not really comfortable with doing things in your head, and sometimes it's just better, you tend to have a little more success in mathematics with using a pencil in hand while you're trying to figure things out. So if you look at the FOIL that I did there, you look at it, and something is kind of funny about it because you end up with only the 18 minus the 12, and you remember something about polynomials when you have this a minus b times a plus b form is equal to a squared minus b squared, right? So, the outer and the inners cancel each other, and you would just end up with the first and the last. So this simplifies nicely to just 6. But doing this little side work is often very helpful to figure out what is 3 root 2 times 3 root 2, or -2 root 3 times 3 root 2. By factoring, by taking your factors, and if you notice what I did down here, the -2 times 2 is out front. I put the numbers together and then putting the radicals together, root 3 times root 3, to put them, and you can see that, oh, that's 3. And then the first one, that's 4. Okay, much easier sometimes. Okay, so there's that one. And then you have the quotient of the roots is equal to the root of the quotients. So you have the root of 75 or the root of 3. Both of those are irrational, but they also have a common factor of root 3. And so, but if you take the whole root and over 75 over 3, then you just get 25. Remember, you could take square root of 75 and you can make it square root of 25 times the square root of 3 over the square root of 3, and you can do the same thing. Bam, bam, they're done. That's always harder. Sometimes it's harder to see, but if you can do that and you see it, great. You get the square root of 25, your answer is 5 for this. But again, it's using this rule, the rule for the quotients. Okay. Then here in this example, we have 63 and 7, which are a common factor, the same roots, same index. So you can bring these two fractions, two roots together as one, and we divide the 63 by 7. And the x has to stay there, but we have a y cubed over y, which makes it a y squared. So we now have the square root of 9xy squared. And I'm just going to separate those factors, and I get my final answer of 3y square root of x. Then you have the 54 and the 2 have a common factor. Then you have powers of x's and powers of y. So I bring it together in one fraction. So I have The quotient of the roots is equal to the root of the quotient. So we have 27x cubed y squared, and then we factor that out, pull out the perfect square factor, extract the perfect square factors as one factor, the square roots, and we have this answer, okay? 3xy, square root of 3x. Again, the green highlights for what can be extracted, and the red highlights for what must stay under the root, okay? And then using rationalization, radical rationalization, so many RA words. So this means, what does it mean to rationalize the denominator? It means to eliminate the radical from the denominator. So what we do is we multiply the numerator and the denominator by a radical that will get rid of the radical in the denominator. That's what this is. This is the process. So we have the example 6 over root 3. So we're going to multiply that one by 1, root 3 over root 3. And we get 6 root 3. And then we multiply the square root of 3 times the square root of 3, and we just get 3 in the denominator, giving us a final answer, then simplifying the fraction, if needed, to 2 root 3, okay? So if you look at all these, I'm going to highlight the radical denominator. So in the square root, we're going to get rid of the square root of 5. We don't want a square root in the denominator, so we multiply by square root of 5 over square root of 5. And you can see that we end up with a 5 in the denominator. Simplify the numerator, and we're finished. So now with the cube root, we look at the denominator, and it's 4, which turns out to be 2 squared. We need cubes to extract the root in the denominator and just get rid of it, essentially. So we're going to multiply that in blue. We're going to multiply by the cube root of 2 to the first, because we want a 2 cubed in the denominator. So the cube root of 2 to the first over the cube root of 2 to the first, and that will do it for us. So when we get down here to this step, we've got the cube root of 4x over the cube root of 2 to the third, thereby allowing us to extract a 2. And we end up with our final answer, the cube root of 4x over 2. And then we have a couple more examples here. You can see that I just took the denominator that I have here and said, okay, I need a 2 cubed, so I'm going to multiply by 2 squared. I need an a cubed. I have an a squared. I'm going to multiply by a to the first. I have a b, so I'm going to multiply by b squared. And these are all under the root. So once I multiply by this power of 1, this value that's equal to 1, then I multiply straight across the top. A times 4, 32. A times a is a squared. And then b to the 4th times b squared is b to the 6th. Now, this last one, I can still extract that. There's a couple other things I can do, but I'm running out of time here. So I'm going to put 3 dots here. This will continue, CONT, and see if you can get the final answer. And then I did a little work here on the last one. I'm going to have you just look at that and see what you think of it, and try to understand what I did there. It's a 4th root, so I need 4th powers with this one. But I first looked to simplify under the root. And there's a little Peanuts comic for you, and I will see you Monday. Try to look at some of the work that I gave you. I will send you the answers, or you have the answers for the 2.1 worksheet that you have to finish. And have a great weekend. This is Mrs. Allen, Allenator, out.